Aloha, my name is Jerry DiPietro. I live in Kaloa. I am a member of GMO-Free Kauai and the president of Hawaii Seed. I welcome you all tonight to the Kaloa Neighborhood Center to hear Dr. Jonathan Latham speak. Hawaii Seed is really honored to be hosting Jonathan tonight. Thank you all for coming down. It should be a very interesting talk on some new material. I wanted to start out by thanking all of you guys who have touted our GMO-free Kauai bumper sticker for the last 15 years around the Garden Island. It's made a huge difference. And I wanted to also congratulate us as an island, as an island chain, for the victory at the legislature. We know that we need to do much, much more for the people in Waimea. From Polihale to Lihue, we still have much further to go, but it is seen as a substantial victory around the world. People have been working to ban single pesticides. It's not an easy thing to do, so to ban something as toxic as chlorpyrifos is a great achievement. And we hope to continue with the momentum and build off of that for the safety of the families living closest to these agricultural fields. So tonight, thanks to the generous donations and granting from the Warsh Mott Legacy and the CS Fund, and also Series Trust for printing our red books. Please, all the materials on the table are free. Please help yourself at any time to water and poo-poos. And tonight we will be hearing, as I said, from Dr. Jonathan Latham. Dr. Latham is on his way to Australia, so we're very happy to have him visiting. He was on Oahu last night, Kaloa tonight, and Maui later this weekend or next week.
The 7th.
The 7th, great. And we will be live streaming tonight, so other people will be able to enjoy this who aren't able to be here. I'm going to give a short introduction to who Jonathan Latham is and his work. Dr. Latham holds a master's degree in crop genetics and a PhD in virology, and is a co-founder of and executive director of the Bioscience Resource Project and the editor of Independent Science News. And we're very pleased to have him here tonight. Please give him a warm welcome.
Well, thank you very much for that welcome. It's a super pleasure to be here on these islands, these spectacular islands, that are the epicenter of crisis, right, in our agricultural system and our understanding of science, and in many other areas. The issues that are manifested on these islands are kind of representative, right, of what's going on in our society as a whole. So what I want to do tonight is, we have a lot of research projects that I could go into. What I've tried to do is give different talks on each of these islands, so that what I'm going to do is encourage people to go, and occasionally I'll refer to the talk I gave last night or the talk I'm going to give on Maui. So each one is basically different. The message, I'm not going to contradict myself in that sense, but the message is basically similar, but what happens is that there's so much evidence in favor of what I want to show you tonight, that what I'm offering is something quite different in many ways, but you also want to know the evidence, right? What is the actual supporting data for what I want to say? So what I wanted to do was bring different pieces of evidence to bear in each talk. So the kind of outcomes are a little similar, but I hope that you'll find that the evidence in each case compelling. So we have a small non-profit. Its focus is food and agriculture. The reason why its focus is food and agriculture is that, can we move this slide? So, just to backtrack a tiny bit, this is the website that most people know us from. right? It's called Independent Science News. Most of it is about food and agriculture. But we do investigative journalism as well as independent research that we publish in the scientific literature. Next slide, please. So our focus is food and agriculture because food and agriculture is the nexus of our ecological and social crisis. If you think about concerns, if you're concerned specifically about climate change or specifically about water issues or specifically about coral reefs or specifically about rainforests, you will find if you trace back those causes far enough that almost certainly they will primarily come back to agriculture, right? Agriculture is occupying such a humongous acreage on this planet that it essentially becomes the cause, even of things that you might not expect, like immigration. For example, the immigrants who are in many cases coming to other countries is because they've been displaced from the land, right? So agriculture is the nexus of all these issues. And what's interesting about that nexus is also people are coming to understand the key role of agriculture. And so that is what the food movement is, right? One of the positive developments that I really strongly see, and I've written an article actually called Why the Food Movement is Unstoppable. And the purpose of that article was to kind of explain and understand the food movement, and a lot of it has to do with the fact that if you eat well, and you eat food that's not polluted with chemicals, and if it's local and so on and so forth, what you end up doing is solving all of these problems all at the same time. Right? So instead of focusing on climate specifically, or rivers and lakes specifically, you can focus on the food, and it's actually a really powerful lever to organize change. And that's what the food movement is about. These people are simultaneously solving many, many problems in our society. So, and the second part of our mission that we see is understanding the ideas that lie behind the kind of directions of our society, right? What are the mental structures that cause us as citizens or corporations or officials of the government to act in the way that they do? And our feeling is that these things are not enough understood among ourselves to actually act in a effective way. And so what we've done is spent a lot of time trying to understand what those ideas are that drive our society. So an example of that is many people believe, because they've read it thousands of times, that we're approaching a food crisis, right? That at some near point in the future there will be some kind of population overshoot or whatever will cause there to be food insecurity because of a lack of supply. And what this story is a myth, right? It has no basis in science, in modeling, in any kind of evidence. But it portrays agribusiness as our saviors. Right? That is its purpose. Right? It's repeated and repeated and repeated by all kinds of people who have an interest in producing more, overproducing, selling more chemicals, selling more GMOs, right? But this entire narrative is a myth. It has no basis in evidence. So this is the kind of story that we would like to share with people, right? Because many people don't buy organic food. In my experience, people don't buy organic food because they think it's immoral. Because if they buy organic food, then somebody has to starve, right? So the agribusiness is portraying this whole battle over the food system as a moral battle. And it is a moral battle in many ways, but it's not that moral battle, right? This is about something different. But it gives them this narrative gives them an opportunity to portray themselves as the good people in all this, which they're not. So I'm not ready to change it. So this is a project that is part of that narrative. Right? It's a question of how do we understand the role of our government in the regulation of chemicals that are sprayed on our food, in our fields, that end up in the waters and oceans, and essentially in our bodies. And so we essentially, this picture is Oregon, right? This is the backwoods of Oregon, and there's a lady called Carol Van Strom, who you'll see in a minute. She lived in those backwoods, homesteading, minding her own business with her 4 children and husband. And one day a helicopter comes over and sprays her, and this is 1974. Comes over and sprays, and the children are sprayed, the animals are sprayed, the consequences are the fish die in the river, her children become sick, and you know, it's a very concerning event. But she doesn't worry about it too much, and until it happens again. Right? The exact same sequence of events happens again. And she decides that there's no way this is an accident. Right? This is what, turns out what was being sprayed on her was Agent Orange. So Agent Orange was commonly sprayed, right, until she played a big part in its ban, was commonly sprayed in the woods of the United States. And basically at the end of the Vietnam War, the chemical industry didn't know what to do with all this Agent Orange, so they brought it home. And so she embarked on a kind of an odyssey to try to understand what the EPA knew about that chemical and what, or those chemicals are, because Agent Orange is a mixture of 2,4-D and 2,4,5-T. So she wanted to know who knew what and when about the toxicological consequences of those chemicals. So she starts sending in Freedom of Information Act requests. She starts asking questions of legislators and so on and so forth. And she works with other non-profits. And she gets involved in lawsuits. She obtains discovery documents. She obtains whistleblower center information. And she develops a huge collection of papers that are internal documents of the EPA, of the chemical industry, and other regulators. And those are the basis of the papers that we have saved for the internet. Right? She saved them in a paper form. And the reason I know about them is because she was writing for our website, and she had all kinds of claims about the collusion of the EPA with the chemical industry, which I had never heard, stories that I'd never heard before, and that but she couldn't provide the evidence, right? I mean, I live in New York State, she lives in Oregon, and she could not support what she said with PDF files that I could share, that we could put as supporting evidence for the stories she wanted to write. And so I made some phone calls and discovered that, what was known about, it turns out that Carol Van Strom is reasonably well known in veteran circles and many circles of people who are concerned about environmental issues. Can we have the next slide? So that is her on the left, actually. The gentleman on the right is Peter von Stackelberg. So he is a person who was involved in this project. So what we ended up doing is raising money to basically scan all the documents that Carol has. So this is her office, and she has a barn where all these, basically 3 tons of documents, nearly 3 tons of documents were stored. So these are the contributors to this project. So these 3 individuals supplied papers. The people who actually did the work are these individuals, and then we were one of the organizers along with the Center for Media and Democracy. So, and we got financial support. Next slide, please. So we're talking about 20,000 documents, about 250,000 pages, somewhere around 2.5 tons. They come from Freedom of Information Act. They come from different government agencies. They come from different companies, some of whose names you'll recognize. And they primarily are about dioxins, pesticides, and PCBs. So dioxins are the contaminants of Agent Orange that were primarily responsible for all those birth defects and veterans, harm to veterans. Next slide, please. So this is the website of the poison papers, and you go to this website, and then it will take you to another website called Document Cloud, which is basically a repository of all these documents. And you can search that website, and if you want to search your island or your least favorite chemical or whatever it is, you can go and do that. And if you're lucky, you'll troll up some more information. So this is Carol's story. She was very important in essentially the ban of Agent Orange in the United States. So without her work, it's unlikely that ever would have happened. And she, so essentially what was what was banned actually, Agent Orange is two different chemicals, 2,4-D and 2,4,5-T. What was banned is 2,4,5-T. And she wrote a book called A Bit of Fog, which I recommend to people. It's a harrowing book, right? But if you want to know the truth, then it's a pretty good one. So I recommend that people take a look at that book. Next slide, please. So what I want to do today is talk about the science of dioxins and the EPA's role in that. So last night I talked about fraud in chemical testing. I talked about how companies essentially are supplying data to EPA that they know is not true, and that is being used as the basis of chemical approvals. And I'm going to give you another angle on that story tonight. When I talk in Maui, I'm going to talk about the EPA's evaluation of those chemicals. Right? So there's a kind of a long process that takes years that goes through, in which there's evaluation of a chemical. Starts with the production of the chemical, and then it goes to the testing of the chemical, then it goes to the evaluation of the chemical by the EPA. So this is a long bureaucratic process. First of all, I should give you some information about the science of dioxins so that you know the background to this. Because there's a whole ton of scientific literature about the toxicity of dioxins that has basically concluded that these are astonishingly toxic compounds. There is no such thing as a safe dose of dioxins. Yet we all carry those chemicals in our bodies today, every single one of us. Everybody on the planet has been contaminated by these chemicals. These chemicals basically do not break down. The only thing that breaks them down is sunlight. And essentially, one of the experts that I talked to about dioxins, he basically said to me, we're just waiting for dioxins to be buried in the sediments of the oceans and so forth, because there is nothing at this point that we can do about the ones that have already been made. And so dioxins, this is the chemical structure of dioxins. They are produced as the byproducts of burning when you mix carbohydrate molecules with chlorine. So basically, if you're a chemist, you'll recognize this as a very stable structure. This is essentially, if you take burning through to an end product, if you burn something really, really hot, then it ends up in very simple molecules. If you burn something at just a kind of medium temperature, what you do is you accumulate in that chemical reaction stable products. And dioxins are stable products. And so these chemicals, which are basically composed of two different benzene rings that join together, they are quite stable products. And there's a whole family of chemicals. This is 2378 TCDD. So TCDD stands for trichloro-dibenzodioxin. And there's a whole family of these depending on where the chlorine molecule ends up. So a chlorine molecule could end up here, it could end here, here, here. But also there can be, each one of these little nodes can be chlorinated or it can not be chlorinated. So that gives you a whole range of slightly different molecules which essentially accumulate in these chemical reactions. And the kind of chemical reactions that they accumulate in are ones, for example, this is the herbicide 2,4,5-T. If you imagine two molecules of 2,4,5-T stuck together, what you end up with is dioxin. So essentially, in the manufacture of 2,4,5-T, depending on the conditions that you use, you will end up with more or less quantities of dioxins. So these products are produced anytime you have carbon and chlorine. So don't burn PVC, right? Because PVC ends up burning, it ends up in the smoke, right? So, and the first scientific description of the toxicological consequences of dioxins were produced in 1957. And these researchers showed that ingestion of dioxins gives a rash, right? A sort of bumpy rash. I'll show you some photographs of in a minute. And the other thing that you need to know about these chemicals is they're lipophilic. What that means is that they accumulate in your fat, right? If the only source of fat on this planet is living organisms, okay? So it means that chemicals that are lipophilic will all migrate into all the living organisms on this planet. Okay? So they end up there. So they accumulate in the food supply. So if you eat organisms that have fat in them, then you will basically likely take up most or all of the dioxins that are in that organism. And that's how they accumulate. You know, you basically accumulate them over your lifetime. And the only organism, by the way, that feeds higher up on the food chain than a person is a baby, right? When you breastfeed that baby, they accumulate your dioxins. Next slide. So, the official, what I gave you is the scientific understanding of dioxins that we have at the present. This is very different from the chemical industry understanding of dioxins and the EPA's understanding of dioxins, judging by their statements and actual public action. The chemical industry believes that dioxins do nothing other than produce a rash. Right? This is a picture of the rash. It's not a trivial rash. It takes many years to go away, but it's also accompanied by things like loss of libido, liver toxicity, various other consequences that are the kind of the real harms, if you like, of dioxins. The EPA, right, basically does not regulate dioxins. They do because they're not made, in part because they're not made deliberately by the companies. Basically, EPA is in a position to pretend that they don't exist, right, legally speaking. Next slide, please. So, but if you read the papers, you find out what the chemical industry actually knew about dioxins, right? So there's a Dow report, for example, which is in there, which explains what the chemical, for internal distribution only, what the chemical industry knew and knows and knew about dioxins and when. So already in the 1880s, it was known that chlorinated chemistry resulted in chemicals that were bad for people. That was kind of a law in the chemical world. There were people doing wacky things in the 1880s with wood and coal and whatever, and they knew that if you mix chlorine in there, you were likely to become sick. In 1945, Dow was making special precautions in its manufacture of trichlorophenol, which was basically an intermediate in some of its chemical processes. So this is a chemical compound which looks quite similar to dioxins, right? Once again. So in 1964, Dow in Michigan started to make Agent Orange in large quantities for the Vietnam War. And they, as a consequence of that, ramped up their production. And basically, straight away, started having problems with workers developing these rashes. And essentially, the workers began complaining because they associated these rashes, which are very obvious symptoms, with more fundamental effects on themselves, right? They talk among themselves and they understand that people who work in certain parts of the plant become more ill than people who work in other parts of the plant. So, and Dow has an internal report where some of this information comes from. Basically, the management is basically explaining that the workers are demanding protections from these chemicals. So the workers the company starts by putting a doctor in the building where the trichlorophenol is being made. And then they end up basically walling off the whole thing, right? So nobody can come and go. Because, they're failing to deal with the toxicological consequences of manufacturing these chemicals. So, and in 1965, the beginning of 1965, Dow, is having problems. They're making all this Agent Orange, but they don't know how to solve the toxicological problems. And so they write to a chemical company, Boehringer in Germany. So Germany is kind of the motherlode of chemistry, right? The kind of all the best, it was considered for a long time, the best chemists come from Germany because that's the country where the Haber Bosch process was invented and these, highly, respected chemical companies come from. They're the people who supply the world's chemicals in many ways. And so they write to Boehringer and they say, you know, we've got this toxic chemical and can you tell us anything about it, right? It appears to be a contaminant of the production process, and we have, you know, we want to know more about the conditions. They wanted to know more about the conditions under which the toxic forms were produced, right? Because, you know, you've got an option of running your chemical process at high or low temperatures and with different solvents, or with, you know, there's many choices to be made in manufacturing these chemicals, and you have basically, you know, they changed the process to ramp it up, and that was when they were having all these problems with workers becoming sick. And the answer they get from Boehringer, so they have, basically this is the notes of a telephone conversation, and they send this letter back to Boehringer and say, can you confirm that this is the contents of the telephone conversation? Because Boehringer speaks in German, for example, so there's some communication difficulties here. And what Boehringer tells them is that actually these chemicals are too dangerous even to do research on, right? They're basically saying, you know, we did not want even our research lab people to be exposed to these chemicals because they're so bad. So, and the same Dr. Mertz had told Dow in an earlier conversation about what he considered to be the extraordinary dangers of these chemicals. Okay? So the context of this is that the chemical industry tends not to worry about toxicological consequences, but even these people think that these are extraordinary compounds. So what Dow does is they start testing the products of other companies. Right? Is Monsanto's, right? In this letter, is Monsanto's identical product, is it also contaminated with this toxin? And the answer, what Dow concluded was that Monsanto's trichlorophenol was also contaminated with dioxins, what they considered to be a high level, and Dow thought that Monsanto's product should not be sold. And here's a little description, internal description from Dow of the nature of their concern. So I just copied here on the left. Okay? For some of these slides, I wanted to just write out what's written in here in case people have trouble reading it. But it says, as you well know, we had a serious problem in our operating plants because of contamination of 2,4,5-T with impurities, the most active of which is 2,3,7,8 tetrachlorodibenzodioxane. This material is exceptionally toxic. There is some confusions with the names here. So in the early days of these chemicals, there's no agreed nomenclature, right? So some people are calling them dioxane, some people are calling them TCDD, some people are calling them tetrachloro, you know, and so there's they're all the same thing, basically. This material is exceptionally toxic. It has a tremendous potential for producing chloracne, so that's what they're calling the rash, and systemic injury, right? This is a rather important statement here, and systemic injury. It is present, if it is present in trichlorophenol, that is the product, it will be carried through into formulations that are to be sold to the public and also used in the war. So Dow's next step is to take, basically write to everybody else in the chemical industry and say, we have a problem here. And so they write to Monsanto, they write to Hooker Chemical, Diamond Alkali, Hercules Powder. These are all other companies making and selling herbicides and especially products derived from trichlorophenol. But this is a rather interesting letter, right? This is from 9 years earlier. It turns out that you didn't need to write to Monsanto to tell them about this, right? They already knew. So this is their medical director, and they have already gone through the same process. They wrote, in this case, to BASF, right? Another German chemical company, about an accident that they learned about in 1953. Right, so we're now 12 years earlier. So, and the notes of this conversation are, that I'll read them out, about 10 days following the incident and after initial cleanup. So this is an important statement here. They've already done quite a bit of cleaning down and wiping up of this mess. Dr. Ertl, I imagine is the pronunciation, was asked to expose animals in the workroom atmosphere. Rabbits in open wire cages were placed in the symptom operating area for 24 to 48 hours. There were no obvious symptoms which developed in the animals until 1 week after exposure when they died. Autopsy showed liver necrosis. Ertl thought there might be virus infection or some other cause for death until he exposed additional animals in the department, others in cages suspended inside the supposedly cleaned areas, and some in the adjacent department. All died within 1 to 2 weeks following exposure. So it seems like wherever you put your animals, they died anyway. Subsequently, animals placed in the cages, which had previously been in the department, died of liver necrosis. So even the cages were too dangerous for those animals to live in. So Monsanto already knew. Okay? So, and they're calling it dark sand at this point. So this is after Monsanto receives Dow's invitation to join a chemical company meeting. And they take they look at the letter from Dow, and they write, their dioxane compound must be a potent contaminant. Very conceivably, it can be a potent carcinogen, right? So nobody's discussed carcinogenicity at this point. We therefore will never know how close we are to having another epidemic of nitro, right? And we certainly don't want to go through that again, is what he's writing here to a colleague. So this is Monsanto's medical director. He's writing about a chemical accident that happened in 1949 in Nitro, West Virginia. This chemical accident is famous. Can we go to the next slide? So the reason it's famous is that when Vietnam vets basically sued continuously Monsanto and other makers of Agent Orange, and the government was accumulating evidence about the toxicity of Agent Orange, essentially all the data was toxicity of dark skins towards animals, right? So loads of people had tested the safety of it towards rats and rabbits and mice and all kinds of animals, but no one knew the toxicity towards humans. And the defense of the chemical industry became that there may be all these toxicological consequences to animals, but the health consequences for humans are unproven and may even not exist. So, and the evidence for this statement came from 3 studies that were done in Nitro, West Virginia, right? Because these were Monsanto workers who worked at the plant when they had the accident, right? So there were exposed workers, and Monsanto, and the authors of these papers, right, who were basically, at least one of these people worked for Monsanto, right? Monsanto is the author of these papers. And they entered the scientific literature, and they became the basis for their legal defenses against the complainants of Agent Orange, because these papers show, they claim, that there are no human health consequences of dioxin. Now, we now know that in court cases, Monsanto accepted later that these studies were actually fraudulent. And what is interesting about that letter that I just showed you is that it demonstrates that they knew that in 1956. The medical director had a perfect understanding that that accident had led to carcinogenic consequences. And he says, we don't want to go through that again, right? There's basically an admission of that fact. So, what becomes interesting in this story is, what does EPA know, right? Because they're the people tasked with protecting us from these kinds of accidents. So Dow, V.K. Rowe, he's the person who wrote the invitation to the chemical companies to come to a meeting. Quite a few years later, right, they inform EPA of the health consequences of their contaminants. And this is, HEW is actually the organization that existed before the EPA was formed. The EPA was formed in 1970 by Richard Nixon. Right? The HEW was one of the organizations. So basically they took the chemical testing departments of USDA and HEW and a couple of other institutions. They took those and they used them to form the new EPA. And so EPA knew, right? They call the toxicity quite astonishing. Can we have the next slide? So EPA knew in 1970, but as I told you, EPA actually basically does nothing to regulate toxins in our environment. But there's kind of good news, right? 2010, EPA publishes a document, Remediation Goals for Dioxin in Soil, a Comprehensive Environmental Response, Compensation and Liability Act, and Resource Conservation and Recovery Act sites. So these are basically Superfund sites, right? What standards should the cleanup of Superfund sites be held to? So this is something, right? Can we have the next slide? But it's a preliminary report, right? So they've been known about this since 1970, and they published a preliminary report. Can we have the next slide? It's also interim. It's an interim preliminary report. Can we have the next slide? Yeah. They're not quite the same, right? Because we're underlining recommended. There's also guidance. You want to go to the next one? But it's just a draft, right? So in 40 years, EPA has got that far, right? And I want to just point out how long it took BASF to discover the toxicity of dioxins, right? It took them 2 weeks. They did one rabbit experiment, right? And they knew. So this is the level of incompetence that exists, or lack of desire, really. It's not incompetence, right? It's lack of desire to actually protect the public that exists among the EPA and has existed. This 40-year process, right, that is several generations. The people who initially drafted these information, you'll see, you know, several generations of EPA staff have basically been and gone in the time of the drafting of this legislation. Sorry, draft preliminary legislation. So, but EPA, in reality, understood pretty well the toxicity of dioxins. Right? What they did this is from 1982, right? Still slow, but as the dioxin crisis was unfolding, because basically dioxin is produced, essentially, I should have said this earlier, is produced not only with 2,4-D and 2,4,5-D, but essentially in any chemical reaction where you're mixing together carbohydrates and chlorine molecules and doing chlorine chemistry. And many pharmaceuticals that you ingest, for example, are likely to have chlorine molecules in them. Any of those chemical processes are likely to result in some level of dioxin production. Right? The closer you get in your chemical reaction to the structure of dioxins, the more you're likely to have in the final product. So EPA understands this, right? So they set up a series of working groups. This is the chlorinated dioxin working group. This is the dioxin sources working group. This is the DTF is down here to handle specific policies and future situations. So basically, they sort of divvied up the work, right? But they concealed the existence of these committees from Carol and her Freedom of Information Act request. Right? So she's asking EPA for this information about what they know and when and what's their decision-making process and the minutes of those meetings, but they don't give this information to Carol. and other organizations that are requesting them. So this is basically a secret. This is a secret committee. Yep. Thanks. But this secret committee is already discussing in 1982 the cleanup options, right? And 38 years earlier, then the final draft report was produced. They're already discussing the options for cleaning up superfund sites. Should it be down to 0.01 parts per billion? Should it be 1 part per billion? Or should it be 100 parts per billion? Right? The discussion of the cost-benefit analysis and the feasibility and so on and so forth for these different levels of cleanup. And here's some more evidence that EPA understood perfectly well the toxicity of dioxins. So Agrichemicals, who already knows this, right, at this point, has been told that it should treat the dioxin-contaminated land around Bloody Run with the same level of precaution as it would with plutonium, right? So plutonium is something that basically lasts forever, and there's no safe dose, right? So this is the equivalence of between dioxins and plutonium. So I just want to draw some interim conclusions here. So, the first is a simple thing. We've all been exposed, and if you're exposed, you've been poisoned by dioxins. And that there is basically no solution except to stop making them, because you can't even make them and then purify them to remove them from many of these processes, right? It's just too difficult. And then what are you going to do with the product anyway? So EPA is perfectly well aware of this. It has basically done nothing for 50 years. And they've actively worked to cover up the problem. So they've concealed what they knew. They also did various other things. Congress at one point mandated a national dioxin study, which EPA attempted to derail. They also they took samples when Carol and her friends basically became concerned about dioxin concentrations in their environment. EPA sent out people to take samples, and when they came back with positive results, EPA said, well, basically, we don't trust that method, right? And that's what they told people. The absurdity is incredible, right? You trust the method if it gives the answer you want, which is there's nothing, and you don't trust it if it gives the answer that you do want, right? That you don't want, okay? So why would you ever do any sampling with a method that whose results you didn't trust? Right? But it's like, this is kind of something that drags the whole conversation out for years. So, and here's the postscript was that 2,4,5-T was banned basically successively. So it was removed from the food, banned from the food supply, and then from different uses. And finally, completely in 1985, that 2,4-D, right, which is a chemical that everybody knows, is still on the market, right? And it is contaminated, all 2,4-D is contaminated with some level of dioxins. And depending on where you buy it from, or the timing of which you buy it, and so on and so forth, I recommend that you don't buy it from China. I recommend that you don't buy it from India if you have to spray 2,4-D. I don't think anyone has to spray 2,4-D, but if you feel that you do. And I also would like to point out that many of these issues are agricultural ones, right? In terms of the framing that I offered you at the beginning about many of our issues come back to agricultural ones, for the issue of dioxin is in many ways an issue of agriculture. Right, next slide. So I want to change to a slightly different analysis. So last night I taught quite a bit about failures of chemical testing. So what the papers demonstrate is that there were very extensive failures of independent testing laboratories to be honest and competent. And the papers also document very numerous and extensive failings by EPA to evaluate the toxicological consequences of the data that it was offered. So I'm going to quote from some letters written by senior EPA toxicologist Adrian Gross of the Hazard Evaluation Division, who is famous for exposing what's known, I talked about it quite a lot last night, called the IBT scandal, in which he basically took it upon himself to visit one of these independent testing companies because he detected the likelihood that this chemical testing company, which tested a third of all chemicals used in the United States, including Roundup and atrazine and so on, was basically delivering fraudulent results. And what happened was, when he went to visit that that independent testing laboratory, they called the police on him, right? And he discovered, he basically, you just had to walk in there to realize that they were not conducting adequate scientific experiments. So he's kind of famous for that. But what it means is that we have strong grounds for trusting his descriptions of what is going on inside EPA. And I think that the truthfulness of these documents speaks pretty well to themselves. So just a quick overview of the business of chemical testing. So the chemical industry, in the very early days, the chemical industry would do its own testing. And in some of these examples, from the late 1970s, they still were doing their own chemical testing and giving the results to you. But by this time, there was also a network of chemical testing laboratories that were nominally independent. So these are some of them, and the names I've mentioned of these are because they've all been convicted at some point of fraudulent testing. So essentially what happens is, a chemical company makes a new product. They send it to a chemical testing laboratory. They probably will already have done their own internal testing. But they will send it to an independent lab. That independent lab will test it in a chronic study on rats or mice or whatever they're asked to do. And then that information is then passed to the chemical industry, and then a summary usually is sent to the EPA. And the EPA sometimes, or maybe not, will ask questions about that summary. But EPA, for the most part, does not even see the original data. Next question. Next slide, sorry. So I want to talk about an insecticide that's widely used these days, and the documents describe in detail the approval of that insecticide. So it's an important insecticide in its own right. It also was the first member of the pyrethroid insecticide family. So pyrethroid insecticides are originally the original versions of plant products from chrysanthemums. But these are chemical company synthesized versions. So you can see the very fact that it has chlorine molecules on it tells you this comes from a chemical company and not from nature. So similar products, Permethrin, Permethrin, quite common products that you can buy in Walmart or Costco or wherever. The trade names are Nix, Biomist. The uses are widespread, so people are starting to use them a lot on their clothes against ticks, widely used in agriculture. I was watching a movie made about Hawaii, made by Hawaii Seed, just a couple of days ago, and they showed a picture of a field, and in the corner of the photo was a yellow sign explaining what was being sprayed, and the product being sprayed was Permethrin. So it's used all over the place. And it was approved in 1982 at this level of, this is ADI stands for acceptable daily intake, what you're allowed to eat every single day and no harm will come to you. And the toxic effects of these types of insecticides are basically considered to be neurotoxicity. So many pesticides are neurotoxins because insects are susceptible to neurotoxicological consequences. So in the case of Permethrin, the EPA received 7 long-term studies from 3 different manufacturers, companies who wanted to make this product. And they all submitted separate data sets. And one of them was initiated from an independent testing laboratory, and that was called Biotechnology. So, but here's what Adrian Gross wrote about one of those experiments that was submitted to EPA. So when you submit an experiment to, when you basically submit data to a company, to EPA, when you do these toxicological tests, when you do these toxicological tests, basically it's an agreement between the chemical testing company and the EPA that you will do an experiment in a certain manner and that you'll test certain tissues and you will look at certain things, which is supposedly ensures that if the animals all turn out to have lung cancer, that the company doesn't then forget to send in the data about the lungs, right? So you agree in advance what you're going to test and how you're going to test it, and you agree the entire protocol with the EPA. So he's complaining that large amounts of the data is not being included in the test, right? Which invalidates the statistics and so on and so forth. So the liver is missing in 10 cases, the pituitary gland is missing in most cases, and different animals to kill at different stages, different amounts of data is missing. But any missing data is a red flag, right? There's two interpretations of missing data, right? One is incompetence, and the other is fraud. There are no other interpretations. So, and I'm going to read this for its whole. So he writes, so this is a letter to his superior, okay? That's the same as with the last comment that I showed you. It is worth noting that, as with the previously listed study here, no attempt at examination by the toxicology branch of the original laboratory records for this work was ever carried out. As far as I know, no tissues were examined histopathologically by any of our own pathologists or by any of our selection, and I, for one, know nothing whatsoever on the identity or competence of the pathologists who were responsible for this particular work carried out in the UK. It seems to me that before we can conclude that this study is fully useful in the safety assessment for this pesticide, or that the adverse findings reported are of only marginal concern, we ought to provide for the American public some assurance that our confidence or sanguine attitude on our part with respect to this study are not misplaced. This is particularly important if we keep in mind that for those experimental studies on permethrin which were audited by us and for which pathologists of our own choice have examined the available material, it was determined that either such studies had major flaws in their execution or that the circumstances under which they were carried out were not truthfully reported to us, or the number of tumor-bearing animals in such studies was significantly underreported. Can we have the next one? So, and here's another page from a little later in his report. It says, for this particular experiment, no professional pathologist was in attendance at the time the experimental animals were dissected after death in order to record grossly observable pathological alterations in their carcasses and tissues. So what he's saying here is that if you don't have a competent person present, you can't possibly collect the data on what's going on with these animals, right? So he's saying these experiments are meaningless. And here's a case in which he writes about a slightly different chemical called oxamide. So he's pointing out here that considerable numbers of the animals, in this case, several mice were judged to be in an advanced state of autolysis. Right? So autolysis is basically an animal has died in its cage and is so rotted that you can't actually do an analysis of that animal. Right? So the agreement in this case, which he pointed out in an earlier paragraph, was that the animals would be examined twice daily to see if any of them died, right? Because that enables you to then collect the animals and do an examination of them to find out the cause of death, right? Which is important for the experiment. And he's saying, basically he's implying that, if an animal has been sitting in his cage and is rotted utterly, they're probably not inspecting the animals twice a day. And he points out that many other animals had also advanced post-mortem autolysis, but it wasn't quite as bad as for the animal to be completely unobservable. But it will still inhibit the analysis, and it still implies that the company is basically doing a terrible job of conducting these experiments. And then he points out, I'll read this one too, as noticed with other studies discussed in these pages, this is the company Burroughs Welcome. In these pages, the reliability of the conduct and reporting of this particular work is not touched upon in the assessment, which devotes to it a grand total of 2 paragraphs at the end of its page 7. So he's commenting on EPA's internal final assessment of permethrin. He says, yet we find that in July 1981, the original toxicology branch reviewer of this study drew attention to the fact that the registrants originally reported virtually all tissues from virtually all animals in the experiment to have been examined histopathologically. The same information was given again to the EPA following a specific request for clarification of this on June 29, 1981. Yet, when we insisted on a signed statement to this effect from the pathologist who actually carried out such examinations, a very different story was presented by the registrants. Right? Basically, the company is lying to EPA without any consequences resulting from that. So, and then he ends his analysis of the study of permethrin. He says, basically, you've got terrible data, misreported. And so he writes, I cannot see how anyone in complete control of his senses could place any kind of reliability in any study conducted according to such practices. In view of all this, I would conclude that none of these 7 studies can be regarded as having established that permethrin is safe from a carcinogenic point of view in a reliable fashion. And in fact, he concludes the opposite. The evidence is overwhelming that permethrin has a marked tumor-inducing or carcinogenic activity which is expressed in many different forms. So his examination of the data comes to a completely different conclusion to EPA. EPA concluded basically, you can almost eat as much of this stuff as you like. And he does a recalculation based on his own estimations of what would be the consequence of actually eating what EPA thinks you can eat. And he concludes that depending on the version of depending on how you do the calculations, he says between 1 and 5 per 1,000 human consumers are likely to get cancer as a consequence of permethrin, or using the other method, that the cancer rate from permethrin will be between 5 and 10% of the whole human population. And he concludes, I should think that risks of cancer of this order for a relatively new insecticide are unacceptable to any rational person. Next slide, thanks. So I want to think about how to interpret this data, right? So I presented evidence last night of different departments of EPA, different people, different institutions, not different institutions, but in different separate cases, right? Of basically the exact same phenomenon of EPA being confronted with basically overwhelming evidence of human harm and yet doing nothing about it. And I want to offer a suggestion here as to what's going on. So, when most people understand the EPA to be not functioning properly, they attribute it to one of 2 things. Right? They either argue that there are kind of revolving doors in which people are being essentially offered jobs after they leave EPA, or they come to EPA from a chemical company, and then they're derailing decisions and manipulating the process in that kind of a way. The other idea that people often have is there's kind of a nebulous idea of regulatory capture, right? And regulatory capture is a sort of description that doesn't really explain what is going on. If you look in the academic literature, people talk about regulatory capture. The definitions of it are very vague. Like, is it a process? Is it a result? People discuss whether there's strong regulatory capture or weak regulatory capture. It's not a very clear interpretation of what is, and doesn't explain anything. Right? He's not generating any understanding from that description. So what I want to offer is an explanation of what is really going on in these situations. So I want to point out, this idea actually, it comes from a whistleblower at EPA that I know. It's not fundamentally my new idea. What he points out is that EPA, I'm not actually quoting him directly, I formulated it for myself, but what we think is that basically EPA and its senior administrators serve at the behest of the president. That president does not want to be troubled by environmental concerns. If troubled by them, she is highly unlikely to take the side of the environment or public health. What that statement basically says is that if EPA discovers a problem with an important product or an important company, basically could or should fine a company, a large company, a very large sum of money, and damage its business prospects, for example, that essentially what's going to happen is, because the head of the EPA can basically be fired by the president at any time, what is in EPA's interest is not to go there with the president. Because basically, if you're going to bankrupt Monsanto because they've spread toxic chemicals everywhere, basically you're going to have to get the president's approval to do that. Right? They can't do it without that approval. So everybody at EPA knows that the president is not going to agree to that, because she is not likely to be an environmentalist or to understand the issues, but also is, these are their campaign donors, right? And if it's not their campaign donors, it's the banks that are going to suffer because they've lent this company money and so on and so forth. So the basic understanding of everyone at the EPA is that essentially we as an institution cannot go there, right? It doesn't matter what the administration is, we cannot take that battle into Washington, because even if we wanted to, we wouldn't win it. So what every EPA staff member understands is that they will not be able to challenge these industries. So the only alternative to that is to bury the information that might embarrass them, right? It's kind of like a self-censoring status, right? If you bury the information, especially at an early stage in the process, then nobody at EPA has to be troubled with their conscience or their so on, risk their salaries or their careers in order to share this information, right? There's an expectation that your supervisor, your juniors will not pass that to you, and if you obtain that information, you will not pass that to your seniors, right? So essentially, you have a situation where the ideal solution to EPA is actually to have a fraudulent chemical testing industry, right? Because that means the EPA doesn't even have to receive that information in the first place, right? So it solves their problem. And so what they do, and you can see this in the papers, is they use a whole host of the internal culture of EPA is to use all kinds of pseudo-scientific arguments, such as controls that were not included in the experiment, or going back and having a look to see whether the tumors in the rats were really tumors or whether they were merely lumps of some kind of unspecified kind or whatever. They'll go back and they'll re-examine the data and they will look at it again, and if it still looks problematic, then, for example, things will happen like administrative fixes. What I'm describing are things like the people are asked to do an evaluation on an impartial data set. So you will give to an external reviewer, or you'll give to some staff member half of the facts. And then they will come back with a conclusion that, well, maybe this chemical isn't really so bad after all. But the simple reason is they weren't given all the data, right? So you see these kind of wheels turning inside the administration, whose purpose is to basically to avoid generating any kind of challenge to the chemical industry. So, and what this does is, because many people never see this going on, right? Especially if it happens at the very junior levels, you don't even know that your people, your colleagues, your people in different departments are bearing this information. So you feel quite good about this, right? You feel that you're quite a gung-ho environmentalist, ready to challenge the EPA, the chemical companies if the need arises, right? But basically, the information is being buried at all these different stages. It becomes no particular person's responsibility to bury that. Everybody does their little bit, right? And that's what you see in these papers is the kind of distribution of the burying, of the collusion, if you like, is between all the different steps in the process. So, and what this idea of proactive collusion essentially does is it explains many of the observations that we have. For example, I go to regulatory conferences and I see people at the EPA and they're super comfortable with the people from Monsanto and from BASF. And part of the reason is that the people from Monsanto and the people at BASF, they're supplying them with the logic, the arguments to actually basically bury the data. If you physically can't bury it, then what you do is you come up with kind of pseudo-scientific arguments. And the companies spend their time coming up with pseudo-scientific arguments. For example, if you demonstrate in the toxicological test that male rats develop cancer because of a chemical, female rats don't, you have a series of you have to interpret that data, right? Is it the male rats that are giving you the real results, or the female rats that are giving you the real results? Is it just causing consequences for the male rats? What EPA, the bias of EPA, is basically to assume that every positive result is an aberration. And what they do is they basically see these arguments going backwards and forwards. Well, we didn't see it consistently across the sexes, therefore it's probably some kind of an artifact. Right? And so they will just reach these conclusions, and that will become the conclusion. And then essentially when the argument moves to the next bureaucratic level, the fact that the chemical produced consequences for those male rats will have disappeared from the decision process. So what I think is that the theory of proactive collusion is actually a very useful contribution to theories of government. And so we have the theory of regulatory capture, which, as I said, is poorly defined, was historically an attempt by right-wing economists from the University of Chicago to basically discredit the process of regulation. What they wanted to do is basically argue regulation is hopeless, therefore don't even bother trying. Right? It was a way of undermining the idea of regulation, when the proper way to think about regulation is not that it is a sort of an annoying feature of government. It is the central feature of government to adjudicate between competing interests in a society. Right? This is a very fundamental thing that cannot possibly be imagined away or washed away or disregarded. Right? If you're not doing any regulation as a government, you're basically not doing a single thing. And so it's important that we don't imagine regulation as some kind of a special case of government, because that's essentially what all government is essentially about. And the regulation is discussed in the Federalist Papers, for example. The founders understood regulation to be a fundamental thing. Whether it was railroad rights or whatever it was, you still had to have somebody adjudicating between these interests. So the traditional view of regulation is adversarial. Regulators defend the public interest and registrants fight for approval. And the standard theory is that complications arise because of revolving doors and so on and so forth. And what I want to argue is that proactive collusion, right, basically EPA making arguments internally on behalf of the chemical industry in order to avoid problems, is basically a much more helpful way to understand many government agencies. So it's not a denial that there are revolving doors, and sometimes that's important. But what I want to argue is that the idea of proactive collusion is, what's the right way? It is an important part of a super important part of the process of government. So, and here's a quote. It's one of my favorite quotes from a book, What the Emperor Cannot Do. Right? What I'm arguing here is that this is an old process. Right? This business of administrations basically you know, at the expense of the general public, creating a power structure that basically allows the corporations, for example, and the government to coexist peacefully, right? We end up being the victims in this process, right? If we're not careful and not active enough. And so this is from a story written in 1880, and it's kind of a fun book. It's a set of sort of mythological tales about the real nature of government. And I recommend people, you know, have take a look at. It's short, but it's basically about the fundamental problems of government. Like even a good emperor, right, has a lot of difficulty actually ensuring good outcomes for the population. Supposing some such person existed, because usually there's all these layers of bureaucracy of people who basically don't want the emperor to find out that his people are suffering and starving or whatever. They were, you know, these stories, the officials of the palace will not let the emperor leave the palace, because they know if he leaves the palace, he will find out what the true life of the people is, and they've been telling him that the people are happy and joyful and love him and so on and so forth. Right, next slide. So, and these are the remedies, right, to this situation. Can you imagine that you could actually adequately support whistleblowers? We do not adequately support whistleblowers at the moment. We could actually offer whistleblowers financial rewards, right? If whistleblowers actually could demonstrate their case in a court of law to everybody's satisfaction, we could actually help these people, because they're risking their lives, their careers, and so on and so forth by blowing the whistle. So another solution to this is to make regulators much more or fully independent of the presidency. Right? If you have an institution like the EPA, who's basically you require that independence on the part of that agency. What you could do is make it more like the Supreme Court, or more like the Federal Reserve Bank. Right? Those individuals, the people who run those institutions, are basically much more independent of the president than is the head of the EPA. And you can also separate the rulemaking and enforcement functions of the EPA. Right? At the moment, if you commit a crime like murder, there's a law that was written by Congress about the illegality of that act. There is a police force that will find the evidence and mount a prosecution, and there's a judicial justice department that will supply a judge and essentially ensure the fairness of that prosecution. Right? You divided those functions into 3 different parts. If you break an environmental law, it's probably been written by the EPA in the first place, and the EPA essentially what it does is it writes loopholes into the law so that chemical companies can never be prosecuted. Right? So essentially what the EPA does is they're supplying those 3 separate branches of government all within one agency, and that allows the agency to become inescapably corrupt. So, and just to end this little section here, I've written an article at the back, Unsafe at Any Dose, which is basically about where the science is even in principle capable of distinguishing safe from unsafe chemicals. Because imagine a new chemical is invented. The question then becomes, is it safe for your brain? Is it safe for is it a carcinogen? Is it safe for your immune system? Is it safe for your any other body part that you may want to think about? Is it safe for future generations? There's a whole ton of questions that need to be answered in order to be reasonably assured that that chemical is actually safe. And basically we do not have enough money to conduct enough experiments to actually do that process. We do not have the financial wherewithal. If you think about all the combinations, for example, we release hundreds of chemicals into the environment. They exist in combinations with each other. If you, for example, experience that chemical at different life stages, you will get different results, for example. So the timing and dosage subtleties have huge consequences for the toxicological consequences of chemicals. If that's really true, right, then most chemical testing is basically either invalid or radically inadequate to actually assure safety. Right? So the question then becomes, even if you had an honest regulator who tried their level best to discover the toxicological consequences of chemicals, would they in fact be able to do the job? Right? Could anybody afford to do a job well enough? And of course the other part of this question is, if they did do an honest job, they might well find out that all chemicals are unsafe. Right? This is a potential outcome. Right? And we don't, we have scientific evidence that suggests actually that that is the case. Right? That essentially there's virtually no such thing as a safe chemical. All of them have some effect on you at some point in your life cycle, for example. So, can we have the next slide? So, I want to talk just very briefly about genome editing. So, this is a subject that has political, technical, hazard, all different dimensions. We could spend a very long time talking about genome editing. Because, for example, if you are going to edit the genomes of wild organisms, for example, this will have effects on neighboring countries. You have to think about the consequences for people in other jurisdictions. So you're going to want, in principle, to have some kind of international agreements about the use of these animals. If you apply gene drives to mosquitoes or to rats or whatever, and you've done it and a hurricane arrives next week and takes those to California or whatever, then essentially you have international incidents on your hands. And that situation arises a little bit in the case of GMO crops, but it will become a lot worse when people start gene editing wild species. So I could also talk to you about the technical details of gene editing, and I would like to, but there's a little too much, not enough time tonight. The issue of hazards, risks, and concerns are very real, in my opinion, but the problem with genome editing at the moment is that, for the most part, we do not know what companies are doing with their genome editing and how they're doing it, right? So there's two aspects to the safety issue of GMOs. One is the method that's used to do it, and the other is the consequence that it has for the organism. And it's difficult to separate risks into those two parts. And so, but we don't know much about either. In the case of genome editing, there's a good chance that companies will basically be able to produce edited organisms without passing through any legal barriers at all, right? And that means that if they're not labeled either, then we will not actually know what's going on. So, but we have public relations and media blitz that I'll talk about in just a second. There are patents and interesting issues of patents and commerce. For example, gene editing is often sold as a backyard thing. There's people who are interested in going it alone with engineering their goldfish or whatever it is. But they will run into the problem of patents, right? If you're basically using Monsanto's, so it will be somebody's proprietary technology that you're using, and that you will have to you're likely to end up paying them royalties. So it's unlikely that the little guy is going to become a winner in this game. So, and I've written an article actually, which is at the back of the room, which is about the possibilities of regulating gene drives. So gene drives are basically genetic constructs that essentially spread themselves through wild populations. Right? If you want to genetically engineer species that are not agricultural species, so for example, genetic engineering of crops, the company is multiplying the seed and supplying it to the farmers and so forth. So that's how that species, that organism is getting out there. And in the case of wild species, the benefit of engineering that wild species is only as great as the amount of spreading that gene will do in the wild population. So the idea of gene drives is that you essentially supply a mechanism by which that alteration that you want to make in the organism spreads throughout the population of your choice. Right? So if you want to remove mosquitoes on Hawaii, for example, that you have to supply some mechanism for the spread of the gene that will kill or disable or whatever the mosquitoes in order for that project to be a success. So you need to be engineering in some complex construct into those organisms in order for that spread to occur. Because most genes introduced into a population will just disappear within a few generations. Unless you introduce tens of thousands or millions of that organism. Okay? And in which case it will still disappear, it will just take longer. So this gene editing, arguably the primary interest of these gene editors is actually to introduce the kinds of genes that will spread through the population. So, and this has, multiplies the political, military, international, democratic consequences of this kind of genetic engineering. So, and these are the kind of applications that people are talking about. So some people are enthused by designer babies or the editing, at least, of cell types in individual organisms. Some people by engineering their gut microbiome or organisms that live on your skin, or organisms that might cause microbial contamination of meats, for example. There are people interested in gene editing domesticated animals, domesticated crops, and then there's all these wild species that people would like to, the human imagination of the people who want to do these things mostly runs to killing them, but there are in principle other ways of approaching these kinds of things. But it is a concern of mine that the idea normally ends up being to kill things, and it indicates some kind of philosophical deficiency, in my opinion. And then there's all the military uses that one can possibly dream up. It is putting large sums into gene drives and other forms of genetic engineering. They had a report, which they call Underwater Allies, it was produced by DARPA. So that's the Defense Advanced Research Projects Agency. And they have, idea of genetically engineering, dolphins or octopuses or whatever it is to somehow help them in military situations. So there really are people putting large sums of money into some rather crazy schemes at this point. And, I think it's really all, to me, as a biologist, hugely concerning. Thank you. Next slide, please. So the language around gene editing is really interesting. Right? So it's sometimes in articles it's called tweaking, sometimes it's called editing, with the kind of inference that this is sort of copy editing. You're making these tiny changes to these organisms, and there's an interesting kind of a disconnect between the enthusiasm which people are taking up for these projects, and how they're talking about the wild improvements that are going to be made, but the actual rhetoric around specific actions is we're just going to be changing tiny little things. Right? How is that? There's an interesting question. How do you square that circle? Right? If you're making these tiny changes, why are you expecting these tremendous advances in that technology? And we can discuss that maybe if there's time for questions. But so it's not only the metaphors around gene editing that are kind of misleading, right? If you want to understand gene editing, you need to understand that we do not have the physical capability of doing any of the things that are actually shown on this, except with the exception of this one. There is no enzyme that can basically target DNA at an exact specific place and cut it and induce a single base pair change. There is no such thing. But gene editing as a rhetoric implies that there is such a thing. Right? So this is the media, public relations people basically kind of doing the biotech industry's dirty work for them and positioning this technology as relatively harmless. We used to call, before the latest iterations of gene editing came along, we used to call this kind of technology gene targeting. And gene targeting has more of a kind of connotation of, kind of damage to the DNA, of shooting at things, of not necessarily quite hitting your target, and so on and so forth. And that was a more accurate description of what is being actually done in labs. But this gene editing metaphor is kind of a nice one for sort of quieting down people's concerns about what's going on. So it's a very useful metaphor. And in the same way that we didn't used to talk when I was a genetic engineer, we didn't used to talk about genetic engineering. We used to call it plant transformation. And plant transformation has the same kind of hubristic connotations as genetic engineering, but it doesn't have that kind of control element to it, right? And that vocabulary was also discarded in favor of the genome engineering metaphor, when engineering of an organism is actually a wildly inappropriate description of what's really happening if you change the DNA of an organism. And we'll go into that in just a second. So, and I wanted just to end up, talk about the mechanisms by which the kind of, this is the most talked about method of genetic engineering, of genome editing rather, and this is called the CRISPR-Cas9 system. So CRISPR is the same thing as this guide RNA. It's a piece of RNA that matches onto a target in the DNA and it causes a cut, right, in this piece of DNA. And the cut is not a very precise one, so what you end up with is quite a few base pairs missing from this sequence. That's one of the reasons why I say gene editing is not actually possible at this point. But essentially, what happens is the cell eventually repairs this piece of damage caused by this molecule. Now, what I wanted to do, what I talked about the other night, last night, was essentially what I wanted to do was explain organisms as systems, right? The organism is not a robot. It is not a genetically determined piece of flesh. It is not, DNA is not a control, essentially a sort of organism that is not a molecule that issues instructions, right? It doesn't tell your organism how to be. Essentially, an organism is a it's a self-organizing, an organism is a self-organized system that is essentially, it's not deterministic, right? It's basically a system, or it's a process. If I come and talk to you in a year's time, I will be a completely different set of molecules than is talking to you tonight, right? I basically turn over everything and say, I may have the same mole on the side of my neck, but I've got the same mole on the side of my neck because all of me reproduces itself all of the time. You substitute, basically, you turn over 60 kilos of ATP, the energy that's involved in causing this is kind of the energy currency of the cell. You turn over 60 kilos every single day, right? Your molecules are changing continuously, right? That's very different from a robot, right? This organisms are self-organizing systems. It's a very different conceptualization of an organism than is a robot. And I want to just go through the gene editing process with you. So firstly, you understand a little bit more about gene editing. But secondly, what is being described in this little diagram here. So this little diagram describes a protein called Cas9 that essentially is doing a cut at a site matched by this guide RNA. And it uses this recognition site as well to guide the accuracy of this intervention, the cutting of the DNA. Can we have the next slide? So this is a more accurate description of what is actually going on in this molecule. So this is a real, kind of a real image, computer generated, but a much more accurate description of that molecule. Essentially, I think we're going to have to go back one slide. So what you can see from that image is that actually the protein is much more complicated than is shown in this blobby picture here. And that's because the process is much more complicated than is shown in this blobby picture here. Right? For example, this RNA has to be inserted between these two strands of DNA. What does that insertion is this protein. Right? This blob here must somehow push that RNA in between the strands of DNA. Then, this DNA, if for example, if you're going to edit a human genome, there's 3 billion base pairs. This RNA has to be matched up with every single one of those 3 billion base pairs. How is that molecule going to do that? Right? It basically has to go through sift through your entire genome and move this RNA through this piece of double-stranded DNA. Right? It's going to go along the entire chromosome, or basically hundreds of meters from here is where it would end up. So this molecule, this protein, must do that process. Probably what happens is it pulls, this is kind of a ratchet, right? It pulls on this RNA, and that RNA moves one base pair at a time through the double-stranded DNA. It moves one step at a time for 3 billion base pairs. And every time it moves, it has to test whether there's a perfect match between the RNA and the DNA. So it has to pause at that point and do some testing. Then, if there is an accurate match, it then has to bind to this protein here, and this protein, when that sequence also matches the protein, then some part of this protein comes and cuts, which is not an easy thing, right? It comes on and cuts that piece of DNA of that part and in that place too. And think about it also, in order for the protein to move that RNA one step at a time through the DNA, the protein itself must move along the DNA. So basically, it pulls on the RNA and it takes a step backwards, and it pulls on the RNA, takes another step backwards, right? It takes a very complicated molecule to do that, right? This blob completely misrepresents the biological reality of what's going on in this process. So we could go another one. And what the previous slide actually showed is the spiral nature of that DNA, right? The initial picture showed that DNA is a linear molecule, but it's not. It's a spiral, and it's mixed up with other proteins and so on and so forth, right? So the biology that we get taught, kind of the take-home message of the biology that we get taught, is that actually we told usually a very, very simple story of what's going on in biology, when the reality is a dynamic and fundamentally different process. So this wrestling is a pretty good analogy of what's going on, right? This blue wrestler, in order to win this, forgive me if I don't know anything about wrestling, because I don't. But this blue wrestler is trying, I believe, to get this red wrestler's shoulder on the ground. So he has to put his knee on his arm, and then he's trying to keep this leg out of the way. So he's pulling on that leg, and then he's got his arm wrapped around this leg to stop that leg causing some trouble. Right, and then somebody's got their arm under here, and I don't even, it's his arm, I think, holding this red arm in place. And that is the process, right? It's this wrestling that is going on when that protein is doing that process. Can we go to the next one? This is pretty much the last slide. So this is what the protein more accurately looks like in real life, right? What you have is a whole series, right? A wrestler is made of levers and muscles and joints, right? Proteins have levers and muscles and joints, right? These little spirals are the levers, right? So you've got this rigid structure here. At the end of this rigid structure is a joint, and that is attached to another part that will no doubt will be a pulling part. So basically, this whole series of proteins, in order to do this thing, basically doing these kind of yoga motions. It's like going from, I don't know how many people here do yoga, but it's basically going from downward dog into cactus pose or whatever it is, and then into warrior 3 or whatever. It's doing this huge complicated thing in order to move that protein, that RNA rather, through the DNA, pulling it, stepping it back, pulling it. So I just wanted to end here with kind of a description of the complications of biology, right? That you never get explained in school. That was never explained to me even in graduate study, right? We have this very complicated world in front of us that we apply all these super simple solutions to, right? And then we wonder why they don't work, right? Well, it backfires on us, right? And so I just wanted to end with that point and encourage you to watch the talk that I gave last night and also the one in May, because each talk is going to basically be fundamentally different. So I'm just going to, I think this is the last slide. I just want to thank our volunteers, and I realize I've gone on well over an hour. This is my kind of co-conspirator, Alison Wilson. He's a co-founder of the non-profit. And these are board members and various volunteers that we've had currently or over the years. And I would really encourage you to visit our website, especially this one, Independent Science News, which has essentially analysis of the food system and so on and so forth. So I'm sorry for going on so long. I probably should have stopped before we got to gene editing and so forth. But I'm very happy to answer questions if that's helpful.
In regards to the last talk, so it's a matter of flow for life with down to that level. It's a matter of movement then, just like in yoga it is like about flow.
Mm-hmm.
The energy flow, is that like for health?
Mm-hmm.
I'm asking on a
Yeah.
DNA level.
Yeah.
Is that what you want? You want things to be like moving?
You know, we don't really know, right? We study these processes using electron microscope. All these processes are studied mainly as flash moments, kind of fossilized, crystallized, right? Those are crystal structures in which somebody has basically examined that protein at a single moment in time, right? And if you could crystallize it under different conditions, and you could see what its structure looked like in a different part of the process. But people rarely do that. I do have a great video that you can find online. If anybody wants to watch a great video, if you Google the F1, F0 ATPase, and there's a bunch of videos online. What it is, this is a multifunctional protein that is a molecular motor, right? The natural world has motors that work exactly like your car motor does, in the sense that you have basically rotations going on inside a stable structure. So it's basically a turbine, right? This is the energy generating molecule of the cell. And it functions, basically, it's turning a gradient into energy. And the gradient is of hydrogen atoms. And essentially you can see that the molecule basically moves around it's exactly like a turbine, right? Stuff goes up through the middle that causes it to rotate. F1, F0, ATPase. So ATPase means the enzyme that makes ATP, and ATP is the energy of the cell. But essentially, we don't know too much about the dynamic nature of the cell, really. What we can make guesses, in a sense, as to what must be going on. But you have to, in order to make good guesses, you have to understand this very subtle, moving, kind of process. Like your own body is a great analogy for how a protein functions, probably. That's why, I was interested in the wrestling picture, because, the system is full of water. There are energy points at which, energy molecules are being applied. So basically, external forces are causing this process to happen, right? Energy must be supplied to that protein in order for it to work. And the energy must be supplied probably at the right time or the right place or whatever it is. And there are systems for making it go backwards, and there are systems for making it stop, and there are systems for making it go faster. And so we can guess, we can speculate about many of these things, but in reality we don't actually know. But biology is presented, we present ourselves as being static organisms. Right? This is what I discussed last night about basically there are organizations like the Rockefeller Foundation who basically turned biology from being the study of whole organisms into being the study of molecular biology, right? Which is the study of very, very small things. And the Rockefeller Foundation are famous as eugenicists, right? What does eugenics imply about an organism? What eugenics implies is that there's a very small molecule or some very subtle things that exist inside you that that you can inherit that basically are issuing instructions, right? That make you be a criminal or not be a criminal. Make you have IQ or have a high IQ or a low IQ. It gives you good social graces and so on and so forth. This was the basis of eugenics, right? This is what these people, you know, if you're a eugenicist, you have to believe that, right? This is what Adolf Hitler believed, right? Was that basically Jewish people, mentally ill people, gypsies were incurable, therefore they had to be wiped out, right? But he was basically taking eugenic philosophy and taking it to its logical conclusion. But the understanding of that eugenic philosophy is that somebody cannot just be changed, right? If you don't like the way they behave, you can maybe have a conversation, you know, we understand, you can have a conversation with them and ask them to behave differently, or maybe change the law, or change the incentives, or whatever it is. But eugenics is about the static nature of organisms. And that is the philosophy of biology today, right? Is that organisms basically don't change. And there's all these implications to that, right? I believe that our fear of death basically comes from the idea that you don't understand that you can change, right? And so we fear that change, right? Essentially is what we're doing when we're fearing death. So we basically, the death is a kind of insult to our biological understanding that we have. And we don't want to face that insult because all the way we act in the world depends on our understanding of each other being basically static and unable to change. We don't see people like that. We don't see organisms like that. So we have this whole fixation in agriculture, for example, on plant breeding. Right? We don't like to change our agricultural system to use organic methods and change the system and change the context of the organisms. Syngenta just wants to come and breed better crops, right? And they want to breed better crops because they think that the genetic determination of the actual species that you eat is the way to affect change in the system, to make better crops, right? And so you have gene editing. The point of gene editing is you basically fall into this trap of imagining the only way to affect change in the system is by altering the DNA of that organism. But it isn't the only way to affect change. There's a whole ton of ways to affect change. But the reason for the enthusiasm, right, around gene editing is the idea that many, many people in government and big business and so on have, is that is the only way to affect change, right? That's why they're so excited about it, right? So when I said, why are they talking about tiny tweaks when they expect such a humongous benefit? You know, we're told that if we reject gene editing, we're rejecting progress and improvement of, you know, all these different systems, that we're rejecting all these wonderful benefits that are going to happen. Well, if the paradigm is that, that's the only way to affect change, that's the logical interpretation of the benefits of gene editing. But the paradigm is wrong, right? The paradigm, organisms basically don't work that way. You cannot just change the DNA of an organism and get many, and achieve all these tremendous outcomes, because DNA is not the only source, only causation that exists in organisms, right? We basically, what our society does, we privilege DNA as an explanation of biological change, right? We basically think that DNA is going to do all the work for us that we would rather not do in our social policy or our law or our education or our communication with each other. So we have this kind of ideology that the food movement and that we as ordinary people basically need to overcome, right? So we have a fundamental barrier between the way, there's a fundamental difference between the way biology as properly understood will cause you to think, or that alternative medicine will cause you to think, or that yoga will cause you to think, or traditional knowledge will cause you to think, and the way that we think actually as a society, right? That's why the people who rise to the top are Rockefellers and Gateses and stuff, who believe most ardently in this genetic determinist nature of an organism, which is not supported by any science, right? They think it is, right? They think we've thrown all this money at the Human Genome Project and that's demonstrated something or other, but really it's demonstrated very little.
altering things, thinking in terms of you're going to make things better and changes. But you know, the ultimate consequence is you have no clue what you could be affecting and what balance you could be throwing off. And we could end up, I mean, kind of like in a sci-fi movie, into something, some organism that is like we've never experienced, we've never, or even a human being that's affected by all these changes in the DNA and the genes that, who knows, we might end up with something horrible. So what do you do then? I mean, do you just go throw up your hands and say, oh, mistake, and let it go wild and kill people and so forth? That's really dangerous. And I don't see the point in doing that because we're not God. We can't change things and think that it's all good. If we were God, yeah, because we know all of it will be good. We're not. So when you're doing these things scientifically with very little knowledge of our brain, of our makeup, of the causes of diseases and stuff, you know what? This is going to be the end of humankind. I mean, if you continue in that direction, I fear for humankind because you have no idea what you guys are getting into. You have no idea what kind of balance you're changing. You have no idea what could happen, right?
Yeah.
So why are you doing this?
I mean, if you think of organisms as self-organizing complex systems, the word I was struggling to find earlier, the self-organizing complex system means that if you make a change to it, you don't know what will happen next. Right? The organism, you can kind of, you know, biologically, you characterize that as an insult. Right? You change the organism, and two things could happen. For example, one is that the organism just returns to its original state. But nothing, you could have no effect. The other one is that you could have a catastrophic effect on the organism, even from a small change. Right? So that is the reality. I totally agree with that is the reality of organisms, right? And but the biotech industry, for example, you know, goes along with the philosophy that we have in our society that essentially the changes that one can make are controlled, right? And that goes along with the theory of genetic determinism. And but essentially they can't. If they wanted to actually accept the reality, which is that those consequences are not predictable, that is not something you can tell either the regulators, nor your investors, nor the general public, right? They're never going to go with your philosophy, right? Which is correct, basically. And I would even add to it and say, not even God knows what's going to happen when you make a change to the system. No, even if you can had all the information you could possibly want, you still would not know actually what was going to happen.
Oh, except God knows what can happen. He knows what we're fooling around with. That's not good.
So, yeah, so we happy, Jerry, are we happy to keep going? I'm very happy to answer questions. Okay, all right, the gentleman at the back.
Yes, okay. If you wanted to find out what the GMO, when you do splicing in a GMO,
yeah,
you have to study on the Darwin concept, the displacement factor or the strain. You have to relate back to that. And if you actually want to see the characteristics change in displacement, you have to look at the hybriding process of what they do, and you'll see the characteristics change in the hybriding process. That's the way you're going to see the GMOs, is to see the hybriding process of the displacement factor. Except that it doesn't show you the extent of what will be displaced in the GMOs, because the hybriding one, you go into so many steps of process until you arrive to your characteristic. And I wanted to ask you another thing about I think, you know, on the dioxin, I believe they have found accelerant propellant in the sense that, you know, to accelerate the metabolism to disperse in the system because it's systematic and it's such a short-term duration to expire an organism, which is a very complex thing here. So I believe they found like a steroid, anabolic steroids, you know, for people to accelerate their changes in their things. So I feel that in chemistry, they have found ways to destroy insects and plants and things. They found accelerants and to accelerate their metabolism, I believe.
Oh, okay. Thank you. Did you still have a question? Yeah, let's make this, are you okay to make this the last question?
Okay, just where can we view your other talks?
Well, it will be put online. I'm not quite sure. You know, I'll be giving this sort of Maori talk, so they'll kind of form a kind of a kind of collective, if you like, that we should work well together. And Hawaii Seed is going to put that on their YouTube channel. And we also have an Independent Science News YouTube channel where we will put it.
Okay.
I don't have a question, I have a comment.
Okay.
It's Monsanto, French, Monsanto,
Yeah.
right? In French would be Monsanto. I'm calling Mon Diablo. The Diablo means mi débil, my evil.
Right. Thank you very much, everybody.
Thank you.